All right, so continuing our discussion of friction. So as we said, it can be explained by Newton's third law of motion because it's a force. So we're going to talk about force equals ma. Okay, that's going to be our main equation for this section. But remember that because it's a vector, it's the resultant or the hypotenuse of your components. So I could give you components and therefore you could find the resultant, etc. So a lot of times we're going to use it that way. Now, friction, as we said yesterday, is necessary for forward motion. Without it, you would stay in one place, stay stationary. So we talked about the ice skating rink, that if you walked on the ice skating rink with your boots, there's not a lot of friction. So therefore, you'll either slide and fall to the ground, or you'll just slip in one place, and it's a lot harder to move. And that's because you don't have friction. It's also necessary for rolling and spinning objects. So tires in a car, that's where it's going to come into play. And that's its own specific type of friction called rolling friction. And then you have spinning objects, which is why we had a whole chapter on circular motion. So this is all coming together now. So everything you've learned is fair game in this chapter because friction applies to any moving objects. And we studied moving objects forever. But every single time we talked about any object, we always said, this is frictionless, this is frictionless. Well, now you don't have that luxury. Now you have to consider the friction. So we have to learn all of our rules about friction now. So traction is what the friction that helps you walk. The grip between your shoes and the ground, basically, is an example of traction. So friction that makes walking, rolling, and similar motions possible is traction. So I want you to think of traction and friction kind of as the same thing. The same as we say force and weight. They're both force. We just give them a different name because it applies to something specific. So traction is friction that makes walking, rolling, and similar motions possible. Because remember, friction is just a resistance to movement. Okay, so now this traction is making things move by causing that grip between the two surfaces in order for your muscle to be able to propel you forward, or the traction of your tire to help you grip the ground to move forward. Because you know that if your tires wear down over time and you try to go to stop, it's not going to stop as easily because your tire does not have as much traction. So you've already learned this before, but now you're learning how to calculate all the things that go with it. So the notation for friction with traction, if I write a lowercase f, that's your friction. If there's a lowercase t as a subscript, that is going to mean that this is specifically friction that has to do with walking, rolling, or any motion that is enabled by friction. Also describes friction that prevents unwanted motion. So traction could prevent unwanted motion with that same grip. For instance, right now there's friction between my feet and the ground. But I don't want to move right now, so it's keeping me in place. If I was on wheels, like roller skates or something, it's a little more difficult to stay in one place, right? Because you're going to kind of be sliding because usually roller blades are plastic and they're smoother on the bottom, so then you're rolling a little bit. Or you also, if you have traction in your shoes, if you're climbing a mountain or some slippery surface, you want shoes with more traction because it will grip whatever surface you're trying to climb, like a mountain, rocks with very smooth surfaces. And that traction will give you more friction but it doesn't keep you stationary. It just keeps you from unwanted motion. So it gives you more control. That's basically the idea. Okay, so as I said, friction opposes motion. So that means that if I have some force moving this way, friction is moving the opposite way of this motion. So it will be tempting when you write your diagrams to draw the arrow like this, but we're not going to do that because it'll get confusing when you do your coordinate system. So instead of drawing our arrow that way, we're just going to take the tail of the arrow and we'll push it to the left. So if this is my force, whatever it is moving forward, this is my friction force, pulling it in the opposite direction essentially. Rougher surfaces tend to have more friction. You kind of already knew that idea. If you're on a carpet, you'll have more friction between your shoes than if you're on a gym floor. Very smooth surfaces have increased friction.
Wait, Miss Naomi.
Yes.
What do you mean by increased friction?
Okay, so I'm going to read the books for this part. Okay. When the surface becomes smooth enough for most of their atoms to touch, the atoms attract each other, increasing friction. Try sliding apart plates of glass that are stacked together. So if you have two surfaces, two very smooth surfaces, and those are touching, like have you ever tried putting two ice cubes together and then separating them?
I think
Or glass plates or anything like that? It has to do because of the atoms. So it's harder to describe because anything that you can't see is harder to explain why it's going on. Like I can explain you friction and traction because you've all experienced it. But when it comes to, so if I took, you know the glass piece that's in the picture frame in the very front? Okay, so if you have that glass piece, all right, it doesn't have a lot of friction like maybe if you were gonna walk on it. But if you take two very smooth surfaces and put them together, the molecules and the atoms are attracted to each other. And so then when you try to slide it apart, that friction comes from the molecular attraction, not necessarily from the roughness of the surface. Because friction, again, is just opposing motion. And so when you have those two smooth surfaces and they don't want to move, that's friction. So it could come from anything. Like even if you talk about Play-Doh and you put two things of Play-Doh and stick them together, since that sticking them together is opposing motion, that's the same idea of friction. Does that make better sense?
Yeah, it makes sense.
Okay.
Also, another question.
Yes.
Why does rough surfaces make more friction?
Why does rough surfaces?
Yeah, I know by experience you can know it, but why?
Why not?
I think that's like one of those concepts just like gravity. Like that's how it works and that's our observation, so that's why we know. I think that's just kind of how it works. You know what I mean? So let me try to think of it this way. So when the scientists and all the people started to quantify things, right? When you start to quantify things, you're quantifying it and making mathematical assumptions based on what you observe, right? So when the scientists were doing all of their experimentations and all of that, when they came up with friction and they said, okay, this force opposes motion, and on different surfaces you have different amounts of this opposing motion force, and this is what's happening. When they did their scientific experiments, they noticed that the smoother the surface was, the less friction you had and the less opposition to motion. So they just observed it through experimentation. But then they noticed that if they put two smooth surfaces together, that they had an increase of friction. So then they had to figure out, well, why is that happening? And so then after they did their research and did more experimentation, they realized that it was because of that attraction of the atoms to one another. Does that help explain it?
Yeah,
It's
yeah.
like one of those things that it's like, how do you explain gravity? You know, gravity is the thing that's keeping us on the earth. And but how can I explain where gravity comes from? I don't know, because I'm not God. I didn't create it. God created gravity to be that way. And just like he created this idea where if we have rougher surfaces, we can propel forward, because how else would we walk? But then also, how else would we stand still? It's just one of those concepts that kind of needs to exist in order for us to live the life that we were created to live.
I think there's a theory or something between the planets. The planet that has the large mass will attract the planets has less mass or something. So it's like
If you
the
have more mass,
object
you
that
have
has
more
larger
gravity.
mass will attract the object that has less mass or something.
Because of gravity,
Yeah.
is what you're saying. The gravitational pull between the planets is going to be greater if it's more mass. Okay, yeah. So this is when I think of science. Okay, this is my perception. Okay, God, being the all-knowing being that He was, knew that we were going to have questions, and we were going to question why are these things the way they are, right? And God put things in an order, I think, so that it couldn't have happened randomly. Like our brains do not have the capacity of knowing how and why he came up with certain things. And I think that was not an accident. Because if we could know every single thing, and if I had all the answers, and I could tell you exactly why God thought to have carpets so that I could walk, how would I be, what would I have to worship? Does that make sense? Like, clearly I'm not going to have all the answers, and I can study as much science as I want, but there's going to be still more to know, because God has designed things in such a way that only he could have done it. And I think God also knew that we were going to try to explain away his creation. So then we have all of our scientists, Darwin, that we've learned about, and then everyone else who's come after him, who's done research and explained through the naturalistic worldview how things could have happened because of a meteorite, or atoms must have just always existed, and they explain away God. But if things were randomized, so if it was just random that gravity was in existence and we couldn't mathematically contact it, or if the planets weren't held together by gravity or some specific thing that we cannot understand, then we could probably explain it as something being random, or it randomly coming into being. But everything is so specific, even down to we couldn't walk if there was not different varying types of surfaces. So I think it was purposeful. I think God did a lot of things that, like even when you ask, well, why is there more friction at a rough surface? I had no answer. Because
Why do we have an appendix?
why do you have an appendix? And certain things like that you can live without, or you can live with, and they have purposes. And even like the tonsils, and there's different parts of the anatomy that people thought you could just cut out, and then realized how you couldn't really live as well without it, like your gallbladder. You can remove your gallbladder, but then you have a lot of digestive issues and stuff like that. But there's some things that I think that, we can study and we can experiment with. And why did God create it that friction is more in rougher surfaces? And I'm sure if I did a big intense Google search, there's probably someone out there who has explained it. But you ask so many deep questions. Sometimes I realize just what questions I haven't asked myself. Like when I was taking physics, it did not occur to me to ask that question.
Okay.
I mean,
Therefore, I have not found the answer.
I mean, why?
But I think that's.
I mean, why it is impossible to explain friction? Like why? Like I don't understand why it's not rough surfaces. Like Jason is asking, like why is like rough surfaces are has more friction. I mean, this question, is this question really?
Maybe that's a question for the Indian men on
I
YouTube.
mean, no, but like if you put like a rough surface under the microscope, you let microorganism to travel through that space, through that place, right? Travel through that distance.
So if you put something with a rough surfaces under a microscope,
You can see this structure, right?
right? You can see it.
Yeah. So what determines friction is that if a same object traveling at the same speed, like you just test, like there are two types of surfaces, and rough surfaces and the smooth surfaces, and this organism is going to use the same speed to travel, right? Obviously, the rough surfaces will require to travel more distance because it's
Because
not
of friction.
because of the roughness, because the structure is not balanced, the structure is not like uniform, because there are some
Yeah.
things impeding this organism
Right.
to
It's
move
obstructing
forward.
its movement.
Yeah. So, but the smooth one, there are less stuff to impede, like to affect the organism's activity.
Right.
So that's why.
Yeah. Because there's less. Yeah, I see what you mean. Yeah, it makes sense because when you're standing with your shoes with the jagged edges or whatever, it's kind of like grabbing into it the same way our hands would grab onto like a rock if we're rock climbing. Yeah, that's the idea. But his question to me was more like, well, why is it that the rough surface and the smooth surfaces? Like, why couldn't it be the other way around? Is how I thought he was asking the question.
Yeah, and also it depends on different types of organisms, actually.
Yeah,
Yeah.
obviously, because even I'm gonna have more friction between my sneakers and the floor than I would my bare feet. Or even when you put socks, it makes your foot have less friction between a smooth
Yeah.
floor that I might be able to grip with my bottom of my feet. But that's still the same concept as if you put on socks, if you have your bare feet or you have your sneakers, each one increases the type of surface in order for you to have more friction. Because of what we know, that the rougher something is, the easier it is for our whatever it is we want to grab onto the surface to grip it. But if there's no particles to grip because it's just smooth, then you can't grip onto it. But why is it that way? I think God just designed it that way.
Is
Okay.
there a thing that's absolutely smooth and just